Okay guys, I'm going to walk through the first example from tonight's homework with you so that you can remember exactly how to do this and complete the rest of it on your own. So let's talk about the instructions. You're going to place the ordered pairs into the table, plot them on the graph, and map the relationships for each relation. So that's what each of these different parts of the assignment are. And in the end, you're going to state whether or not that relation is a function and how it is that you know. So, piece by piece. What we have first is we have our group of ordered pairs. The first thing we're going to do is put those into our table. And once our ordered pairs are in the table, we're going to go ahead and move on over to our graph. And you're going to put each of these points on the graph. Start with the point 2, 6, and I will go over 1, 2, and up 1, 2, 3, 4, 5, 6. I will put a point right there, and so on. And now that we've plotted each of those points, remember, we're not going to connect these with a line or anything because this relation right now, all we have is ordered pairs. We don't have the function itself. We just have, or the equation for the relation itself, we just have these ordered pairs. So all we know are these points. The next thing we're going to do is we are going to put our function onto this function map, or our relation onto this map, and determine if it's a function or if it is not. So remember, we like to put these in ascending order from top to bottom. So I'm going to start with my -5, and then 0, 2, and 3 are going to all go into my input values. And as you can see, the only output we can get is 6. The only y value that any of our input values are going to give us is 6, so that's going to be our only output value. The last thing we're going to do is map each of our inputs to those outputs, and we know that every time we put a -5 into our relation, we get 6. Every time we put 0 into our relation, we also get 6, so we're going to map that relationship as well. Every time we put a 2 into our relation, we get a 6, and every time we put a 3 into our relation, we also get a 6. So now it's up to us to determine, is this relation a function or is it not a function? We can go back to our lesson today, and we remember that in order for something to be a function, each input must have one output value. Now that means two things. It means that we cannot have two arrows coming from any of our input values, because that would mean that these inputs have more than one output. We only have one arrow coming from the -5, one coming from the 0, one from the 2, and one from the 3, so we're good there. And the other way that we can determine whether or not that's true is by looking at our graph, because as you can see, if we were to draw vertical lines, there's no vertical line that we could draw on this graph that would intersect with more than one point in this relation. So because it passes the vertical line test, and also because none of our input values have more than one output value, this relation is a function. So what you guys would write is, yes, it is a function because, and I'm going to say here, it passes the vertical line test. And remember, if it's not a function, you have to state that as well. And you can choose either to state that it doesn't pass the vertical line test, or state that that each input has more than one output. Make sure to use one of your two definitions. Good luck, you guys, and I'll see you tomorrow.